Okay, now off camera we've kind of discovered the answer to the question that motivated all this. And the question is in quotes, except it's not quite in quotes. There we go. Okay? Okay, well that would be at this point, right? Is that point necessarily the axis of symmetry? On the axis of symmetry? Then it's not where this graph peaks, because the graph peaks on the axis of symmetry, doesn't it? Now we also say, well, don't you have the negative b over 2a? That's exactly how you get the axis of symmetry if you know the equation, right? But if you don't know the equation, if we're just looking at the graph, just doing this in terms of the graph's characteristics, we've got to see where the axis of symmetry is, okay? Well, I mean, if I draw the axis of symmetry like here, you're going to tell me that that's plausible. So here's our axis of symmetry, and here's our vertex. Okay.
Should we do a fundamental triangle to figure out exactly that?
Fundamental triangle where?
I don't know, somewhere.
It's not a bad thing to think about, but you really don't have to, but something you do with a fundamental triangle would be similar here. Doesn't the axis of symmetry have to be halfway between the zeros?
Yeah.
Because if the graph is symmetric, if one zero is closer to the axis of symmetry than the other, it's not symmetric.
So do we just
So
add
then we
the
just do the
zeros?
midpoint formula.
It'd be the midpoint between your two zeros, right? And you could use the midpoint formula to find it if you knew what the coordinates were. But remember, the original question was this.
Plus a negative.
Well, there's no reason that these two should meet halfway between the two zeros. You can easily draw it so they don't, right?
Yeah.
I mean, it's already drawn so they don't meet. You have to go to a lot of trouble to make them meet halfway between the zeros, right? And it turns out that they would actually, in order to meet halfway between the zeros, they'd have to have equal and opposite slopes. Okay? That makes sense?
No.
Okay, so, we've taken account of the fact that these things, this maximum does not occur here. It doesn't occur this high or this low. Depends on what the scale is. As I've said before, depending on how steep you want to make it as it goes through the zeros, the graph might go up much higher or it might stay much lower. Okay? It's still going to be a parabola. Okay? Okay, so, we're spending a whole lot of time talking about the way these graphs work because it's important for you to understand graphs and then understand how graphs are related to the symbols in the algebra. Okay? And that's the main profit of studying these. I mean, you might never run into a polynomial or rational function that you actually have to do anything with. But in the process of doing this, in case you do run into it, you'll know where you are. Or at least, those neural pathways will have been reinforced pretty well. Okay? But you'll also have a lot better understanding of graphs and what they're telling you and how they're related to the algebra. Okay? That's the main benefit for most people of studying these things. Okay?